Find all values of theta in the interval 0 is less than or equal to theta is less than or equal to 360 that satisfy the equation sine 2 theta equals sine theta. So the first thing you want to recognize here is that we have this double angle, this 2 theta. So there's really no straightforward way to solve this unless we make a substitution for 2 theta. So if you flip to your reference sheet at the beginning of the Regents test, you'll find out that sine of 2 theta, or I think they do A, but we'll use theta, is 2 sine theta times cosine theta. So we're going to make that substitution right off the bat. We're just going to replace sine of 2 theta with what you see here on the right. And we get 2 sine theta cosine theta equals sine theta. Now you might be tempted here to divide by sine theta on both sides, but that's very dangerous because if you do that, you'll eliminate possible solutions because you're taking away one of the variables that's in the equation. If you want to make sure not to do that, then the better way is to subtract sine theta from both sides, get everything on one side of the equation, and then factor out the common terms. So that's what we'll do. We'll subtract sine theta from both sides of the equation. So 2 sine theta cos theta minus sine theta now equals 0. And now let's factor out that common term, that sine theta, that was there twice. And what are we left with? We have 2 cos theta minus 1 equals 0. And now just like any other factoring problem, how could this equation equal 0? Well, there's two ways, right? Either of these two terms could equal 0. So in the first case, sine theta equals 0. That's one way. And in the other case, 2 cos theta minus 1 equals 0. Well, let's solve this. We could add 1 to both sides. 2 cos theta equals 1. And then divide both sides by 2. So cos theta equals a half. And now when are these things true? Sine theta equals 0 when? Well, we want to know where the sine of what angle equals 0? Well, what about 0, right? Aren't its coordinates 1, 0? And the sine corresponds to the y coordinate. So sine theta equals 0 when theta equals 0. Or, here's another situation. This is 0 degrees, right? What about 180 degrees? This point corresponds to negative 1, 0. So isn't the sine of 180 also 0? Yeah, because the y coordinate corresponds to the sine. If y is 0, then the sine is 0. So theta could equal 0 or 180 degrees. And what about this situation? Cosine theta equals a half. Well, when is the cosine a half? Think about your 30, 60, 90 triangles. Suppose this is a 60-degree angle. I'm kind of giving away the answer here, but hopefully this is intuitive for you and you're used to seeing this on the unit circle. So this is a right angle and this is a 30-degree. Right? So the sine of 60, this is a unit circle, so the hypotenuse is always 1. And the relationship between the hypotenuse and the shorter leg down here is that the shorter leg is always half of the hypotenuse. So that's 1/2. And then the longer leg is root 3 over 2. It's the shorter leg times root 3. That's how you get the longer leg. So the cosine of theta equals 1/2. That's true for theta equals 60. So that's a possible solution. Theta equals 60. And where else is the cosine 1/2? Well, remember your mnemonic. All students take calculus. All of the parameters, cosine, sine, and tangent, are positive up here in the first quadrant, and the cosine is also positive in the fourth quadrant. So if the reference angle is 60, then the other angle that's in the fourth quadrant that we must be after must be 60 degrees away. It's not a very straight line, but it'll do. From the, I'm going to pretend these two lines touched. Hopefully it's okay for you. It must be 60 degrees away from the x-axis. So this must be 60 degrees. But we can't just say that that's theta equals negative 60 because we were specifically given this interval. Theta must be between 0 and 360. So instead of getting to it by going down from the x-axis, negative 60, we're going to go all the way around. And how far is that? Well, that's all but 60 degrees of a full circle, right? So if a full circle is 360, going all the way around to here must be 300. 360 minus 60. And that's the other possibility. And now, just to make sure that these kind of make intuitive sense, right? Because we said sine of 0 and sine of 180 are 0. But what about these? Why do these make sense? Let's go back to the original equation. Sine of 2 theta equals sine theta. Take 60, for instance. What is the sine of 60? Well, it's opposite over hypotenuse, right? So it's root 3 over 2. So we're hoping that sine of 60 equals sine of 2 times 60, which is 120. So sine of 60 we just said was root 3 over 2. We took that from this triangle here. Well, where would 120 be, right? That would be in quadrant 2. So if I drew it, it would come up here to this point. And notice that that has the exact same height, or the exact same y-coordinate, as 60 degrees does. So if this is 120, and I know this is getting a little messy, but notice that 120 and 60 have the same height. So sine of 60 does equal the sine of 120, because this is also root 3 over 2. If I were to draw that opposite side, this would be root 3 over 2. Right? And 300 is also going to work, right? Because sine of 300 is going to be negative root 3 over 2, because it's going to be in the fourth quadrant. And then 2 theta would be 600 degrees, which is a full circle. That's 360. Plus another 240 on top of that. That's going to bring you into the third quadrant, and it's also going to have a sine of negative root 3 over 2. So these will work as well. So there are 4 answers. Theta could be 0, 180, 60, or 300.